Hello everyone, in this video we will study the sine rule. We know that area of triangle ABC equals half multiply base multiply height, and we consider the height here AD. So we can say that area of triangle ABC equals half multiply base. Base is the length of CB multiply its height AD. We know that AD is perpendicular to CB, so we write AD, which equal half multiply CB. We denote it by the symbol A here, so we write A small. Again, the length of CB equals A multiply the length of AD. AD equals AB sine angle B. Okay, so it is equal half multiply A multiply AB. What is the length of AB? The length of AB equals C, length units, C sine B. It is the included angle between A and the C, included angle between CB and AB. So it is equal half AC sine B. Half AC sine B. Also, area of triangle equals half BC sine A equals half AB sine C. So, area of triangle equals half BC sine A, which equal half AC sine B, which equal half AB sine C. And from that, we can deduce that BC sine A equals AC sine B equals AB sine C, multiplying the three sides, the three terms in 2. So multiplying by 2, we get BC sine A, BC sine A. Multiplying the second term by 2, we get AC sine B. Multiplying third term by 2, we get AB sine C. So we can write BC sine A equals AC sine B equals AB sine C. Here we can divide by ABC, ABC in this step. So BC sine A over ABC equals AC sine B over ABC equals AB sine C over ABC. And by simplify, here BC dividing up and down by BC, here we get sine A over A, sine A over A. And here we can divide by AC up and down, so we get sine B over B. Dividing up and down by AB, here we get sine C over C. And from the properties of proportional, we can write the reciprocal of each ratio. So here we get A over sine A equals B over sine B equals C over sine C, and this is the sine rule. It is the sine rule, or you can say it is sine law. Okay. Now, in any triangle, the lengths of the sides are proportional to the sines of the opposite angles. This relation is known by the sine rule. So A over sine A equals B over sine B equals C over sine C. And we will use it to solve problems in triangle. First example here, using the sine rule to find the length of a side of triangle. Example 1, find the length of the longest side in the triangle ABC in which measure of angle A equals 54 degrees 33 minutes. So I'll draw the triangle. Here we have the triangle ABC. Measure of angle A equals 54 degrees 33 minutes. Measure of angle B equals 49 degrees 22 minutes. And A equals 124.5 centimeters. So A here equals, it is the length of BC, 124.5 centimeters. Now, the first of all, we will determine the measure of angle C. We know that measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. It is the sum of the interior angle of any triangle equals 180 degrees. So measure of angle C equals 180 degrees minus measure of angle A plus measure of angle B. And now we substitute. We get measure of angle C equals 180 degrees minus measure of angle A. What is the measure of angle A? It is 54 degrees 33 minutes. And we write it 54 degrees 33 minutes plus measure of angle B 49 degrees 22 minutes. Now we will get the calculator to substitute. Here we write 180 degrees minus 54 degrees 33 minutes plus 49 degrees 22 minutes. Then press equal. This is the result here. It is a fraction 913 over 12, and we press commas. We get 76 degrees and 5 minutes. So measure of angle C equals 76 degrees 5 minutes 0 seconds. Okay, now so I'll write it here. Measure of angle C 76 degrees and 5 minutes. Okay, applying sine rule to get the longest side. What is the longest side? The longest side here, it is the side which opposite to the greatest angle. The greatest angle here is angle C. So to calculate the longest side, it's AB, denoted by the symbol C. We can write C over sine C equals A over sine A. And we will substitute. Now C over sine 76 degrees and 5 minutes equals A. I use A here because it is given 124.5 centimeters over sine A. Sine 54 degrees 33 minutes. Okay. Now C equals cross multiplication 124.5 multiply sine 76 degrees 5 minutes over sine 54 degrees 33 minutes. Sine 54 degrees 33 minutes equals 148 equals 148.3 approximately 148.3 centimeters approximately. Next question. Example 2. Solve the triangle ABC in which A equals 8 centimeters. Measure of angle A equals 36 degrees and the measure of angle B equals 48 degrees. Solving the triangle meaning to get all sides and all angles. Here we have one side and two angles, angle A and angle B. Now I'll draw it here. I'll draw any triangle. Measure of angle A. Here we know measure of angle A at 36 degrees and the measure of angle B equals 48 degrees ABC and A equals 8 centimeters. It is A. Okay, so the required here to calculate the length of AC denoted by the symbol B and the length of AB denoted by the symbol C and the measure of angle C. Now measure of angle C equals 180 degrees minus measure of angle A plus measure of angle B. It is equal 180 degrees minus measure of angle A equals 36 degrees plus measure of angle B 48 degrees, and we will calculate it using calculator here. 180 minus 36 plus 48 equals 96. Press commas, so it is 96 degrees. So A over sine A, it is sine rule. Equals B over sine B plus C over sine C, which equal A equals 8 centimeters, right? It is given. It is the length of CB. So I write 8 over sine A, sine 36 degrees equals B, it is unknown, over sine B, sine 48 equals C over sine C, and C equals 96 degrees. Now you can use calculator directly to calculate B. How? We write the fraction here, 8 over sine 36, close the bracket, equals alpha calc equals B. I'll denote it by the symbol X. Here another fraction over sine 48, sine 48. Okay, now shift solve to get 10.11 4 and so on. So B equals approximately 11 centimeters. And now I'll calculate C. Okay, again I write the fraction here, and I'll use these two ratios in calculator. We have 8 over sine 36, and I'll denote to C by X over sine 96, and I'll press shift calc equal 13.535 centimeters. Of course, here is C equals approximately, and to nearest integer, to nearest centimeters, equals 14 centimeters. Next, here we have another rule, geometrical applications on the sine rule. We have another form to sine rule related to the circumcircle of the triangle ABC. So in any triangle ABC, A over sine A equals B over sine B equals C over sine C equals 2R. 2R, where R is the length of the radius of the circumcircle of the triangle ABC. It is the circumcircle. This circle is called the circumcircle, the circle which passes through the vertices of the triangle ABC. Now, example 3, we have triangle LMN in which M equals 68.4 centimeters, measure of angle M equals 100 degrees, and the measure of angle N equals 40 degrees. Find L. First, find L. Here, the length of the radius of the circumcircle of the triangle LMN, the surface area of the triangle LMN. Okay, first we'll draw the triangle LMN. Measure of angle M equals 100 degrees, and the measure of angle N equals 40 degrees. And the M, here is M, equals 68.4 centimeters. To find L, here, L, where is L? L equals Mn. So L over sine L sine angle L equals M over sine angle M. But L, the measure of angle L is unknown, so I'll calculate it first. It's clear that measure of angle L equals 40 degrees because the sum of the two angles M and N equals 140, and the total measure, the sum of all measures of the angles of any triangles equal 180. So measure of angle L equals 40 degrees. So I'll substitute it here, and we write L equals sine L, sine 40 degrees, equals M, which equals 68.4 centimeters, over sine M, sine 100. So to calculate the length of L, we use calculator again, making the fraction. Shift calc equals 44.6. So L equals centimeters. Now B, the required here is to find the length of the radius of the circumcircle, and we know that L over sine L equals M over sine M equals N here over sine N. All of this equals 2R. So I can use the first ratio here or the second ratio. So R, it is the radius, equals M over 2 sine M. Now we substitute. M is given equals 68.4 over sine 100. Sine M, okay, here is 2 multiply, and go to calculator. We write 68.4 over 2 multiply sine 100 equals 34.727 approximately. So R equals approximately 34.72. Next question. We have ABCD is a trapezium in which AD is parallel to BC and AD equals 7.4 centimeters. Measure of angle B equals 62 degrees. Measure of angle D equals 106 degrees. And the measure of angle ACB equals 41 degrees. Find the length of each of these, and so on. Okay, first we'll draw the trapezium. Now we can't use the triangle ABC because there is no sides. There is no given side here. We don't know the length of any side of triangle ABC. So I'll try to use the triangle ADC. Okay, because we know the length of one of its sides. It is the DA equals 7.4 centimeters. But we need another angle in triangle ADC. Okay, from the given we have AD. AD is parallel to CB, right? It is given. So measure of angle ACB, this angle, equals measure of angle DAC. Two alternate angles. Okay, of course we have AC is a transversal to AD and BC. So I can write here 41 degrees. Okay, 41 degrees. So what is the measure of the third angle? Measure of angle DCA equals 180 degrees minus 106 plus 41. Okay, it is equal. After you calculate it, you will get 33 degrees. Okay, I'll calculate it again. 180 minus bracket 106 plus 41 equals 33 degrees. Okay, so I can write it here, 33 degrees. Don't forget that they're required to find the length of AC and BC here. So in triangle ACD, we get B over sine D, sine 106 degrees equals C here, C, which equals 7.4 over sine C, over sine the opposite angle, sine 33 degrees. And now back to calculator and write this fraction. So the result equals 13.06. So B equals 13.06, of course approximately, and the unit is centimeters. Now the required is to find BC here, BC. Now in triangle ABC, here we have A over sine A equals B over sine B. Okay, but we must calculate the measure of angle A here. It is CAB equals 180 degrees minus 41 plus 62. 41 plus 62. So the result equals 77 degrees. I write it. Now substitute what we get. A, it is unknown, over sine 77 equals B. What is the length of B? Here approximately equals 13.06 over sine A, sine 62. And back to the calculator, we substitute. We make a fraction, A denoted by the symbol X, so A equals 14.41 centimeters. And the required here is to find the surface area of the trapezium. First, I'll calculate the height of the trapezium. The height of the trapezium, I'll consider it AE. Okay, it's perpendicular to CB. What is the length of AE? I'll calculate it now. Such that AE equals B sine 41 equals AC sine 41. Okay, it is equal. What is the length of AC? It is B. We already calculated, equals 13.06 multiply sine 41, which equal here again to the calculator 13.06 multiply sine 41, and this is the result equals 8.568 and so on, equals 8.568 approximately, okay, centimeters. Now what is the area of trapezium? Area of trapezium ADCB or ABCD equals the sum of the two bases AD plus the other base CB over 2 multiply its height AE. Okay, now what is the length of AD? Here AD equals 7.4 plus CB it is A equals 14.41 over 2 multiply its height 8.568. Okay, now go to calculator to calculate it. Equals 0.568 equals 93.43. And this is the end of this lesson. Next lesson will be an exercise on sine law. Exercises on sine law. Goodbye and good